Today's we are study the chapter molecular orbital theory of covalent bonding. So first topic is we have learned the assumption of MOT or molecular orbital theory. So the first assumption is the total number of molecular orbital is a form will always be equal to the total number of atomic orbital is offered by the bonding species. The atomic orbital means S, P, D and F is a atomic orbital, and here the total number of molecular orbital is equal to the total number of atomic orbital. म्हणजे जितके atomic orbital असेल तितकेच number of molecular orbital हे फॉर्म होतील. जर 2 atomic orbital असेल तर molecular orbital पण 2 फॉर्म होतील. Next assumption, there exists different type of molecular orbital. First, bonding molecular orbital and antibonding molecular orbital. Next, the non-bonding molecular orbital. Of these, the antibonding molecular orbital will always have higher energy than the parent orbital. Next assumption, the electrons are filled into molecular orbital in the increasing order of orbital energy. From the orbital with the lowest energy to the orbital with the highest energy. Here, the bonding molecular orbital is a lower energy, and the anti-bonding molecular orbital have a higher energy. Here, the comparison between atomic orbital and molecular orbital. So first, it is the region in space around the nucleus where an electron is likely to be found is called atomic orbital. Molecular orbital is the overlap of two atomic orbital form a new orbital is called molecular orbital. Second comparison, the atomic orbital are monocentric consisting of one nucleus. Mono means one nucleus. And here the molecular orbital are polycentric. Poly means more than two nucleus. Next, third comparison, atomic orbital are found in atom, molecular orbital are found in molecule. Then fourth, atomic orbital have fixed shapes S, P, D and F, and molecular orbital can change their shape based on hybridization. Next, the single nuclei effect the density of atomic orbital, and here the two or more than two nucleus affect the density of nuclei. Next topic, the comparison of valence bond theory and molecular orbital theory. So first, consider bonds are localized between one pair of atom. In MOT, the consider electron delocalize all over the molecule. Second point, creates bond from overlap of atomic orbital means S, P, D, F or hybrid orbital, that is sp, sp2 and sp3. And in MOT, creates the molecular orbital means sigma, sigma star, pi, pi star by combining atomic orbital. Next, forms pi and sigma bond and forms bonding and antibonding molecular orbital. Fourth point, requires multiple structure to describe the resonance structure, and here doesn't require multiple structure to describe the resonance structure. Fifth point, predict the molecular shape using the number of region of electron density. Here, predict the arrangement of electron in molecule. Next, fails to explain the paramagnetic behavior of oxygen, and in MOT successfully explain the paramagnetic behavior of oxygen. So there is a comparison of VBT and MOT. So move on next slide. The comparison between bonding MO and antibonding MO. First point, it is formed by addition overlap of atomic orbital. It is formed by subtraction overlap of atomic orbital. the wave function of bonding MO is given by the equation is psi MO is equal to psi A plus psi B. And here the wave function of antibonding MO is given by equation is psi star MO is equal to psi A minus psi B. Second point, its formation take place when the lobes of atomic orbital have a same sign. Here the same side, and in MOs, antibonding MOs, its formation take place when the lobes of atomic orbital have a different sign. Means here positive and negative, and here same means positive positive or negative negative. Next, third point, the energy of bonding MO is lower than that of atomic orbital from which it is formed, and the energy of antibonding MO is higher than that of atomic orbital from which it is formed. Next point, the electron density is high in the region between the nuclei of bonded atom. The electron density is low in the region between the nuclei of bonded atom. Next point, every electron in bonding MO contributes toward the attractive force, and here the every electron in antibonding contributes towards the repulsive force. So there is the comparison between bonding MO and antibonding MO. So next topic is the shapes of s, p and d orbital. So the S shapes is a circular shape. The p orbital have a dumbbell shapes, and the d orbital have a double dumbbell shape. So this is a shapes or structures or diagram of s,p,d orbital. In p there are 3 orbitals, 2px, 2py and 2pz. And next, in d orbital, the first is 3dxy, 3dyz, 3dxz, 3dx square minus y square and 3dz square. So total 5 orbitals of d orbital.